Again, very important question, most frequently asked in the GTU, the working of the standard hydrogen electrode. You all are aware it is a reference electrode, okay, and very clearly it is stated that reference electrode with having the potential of the 0 volt. And what is the construction? Let us see that. It is a universal reference electrode for reporting relative half cell potentials. You can find out the unknown potential of other cell by connecting with the standard hydrogen electrode. It is a type of gas electrode and was widely used in early studies as a reference electrode in determining pH values. That is standard hydrogen electrode, could be used as either an anode or cathode depending upon nature of the half cell it is used with. See the construction, what it consists. Standard hydrogen electrode consists of platinum electrode, okay. This platinum electrode is immersed in the solution of the hydrogen chloride, that is hydrogen ion, having the concentration of 1 molar. The platinum electrode is made up of small square of platinum foil which is platinized. Hydrogen gas at a pressure of 1 atmosphere is bubbled around the platinum electrode. What happens? Platinum electrode is there, you are dipping it in your HCl solution which is having concentration of 1 molar, then you are passing the hydrogen gas from this with the 1 atmospheric pressure. Whatever is said in this construction will be shown to you in the diagram with some animation. Just have a look on it in order to realize the concept. See the things. We have HCl solution working at standard hydrogen electrode concentration 1 molar HCl solution, that is H3O plus ions. You can see here platinum electrode. You can see here hydrogen gas is bubbled in the solution. Hydrogen gas is bubbled. After that what happens? Electrons are coming out. You can see the process, 2H plus is generated in the solution. So what happens next? Standard hydrogen electrode is given E value of the 0 volt, that is potential value is given as a 0 volt, okay. Then you can see here platinum black serves as a large surface area for reaction to take place, and stream of hydrogen keeps solution saturated at the electrode site with respect to the gas. It is interesting to note that even though the that is standard hydrogen electrode is a universal reference electrode or standard, it exists only as a theoretical electrode which scientists used, and it has a cell potential value of the 0 volts. So it is very important. Let us see the next question, that is question 4A, B and C. Question 4 here, A, consists of the things briefly explain the pH and discuss its importance in the various fields. So this is again the applications of the pH in various fields and its importance. The second question is write a short note on FOSS, that is pitting corrosion and N-type semiconductor, which is having the 5 marks weightage. The C part, that is having electrochemical series and the importance of the electrochemical series, having the weightage of the 4 marks. The very important question that is covered in the GTU. We will be taking up here question 4A. The first thing, the pH, describe with the briefly pH, discuss its importance in the various fields or the different fields. It is having 5 marks weighted. So what we are going to do, we will write the definition, we will write the mathematical form of the pH, and after that we will put up the industrial applications of the pH. What is pH? What is the definition? It is described as negative logarithm of concentration of H3O plus ions expressed in moles per liter to the base 10. So this is actually the definition of the pH. At the same time, you can denote it in the mathematical form. pH is equal to minus log of H3O plus ions. Okay, so this is actually the pH indication in the mathematical form. Okay, so let us move ahead. What is the application? What is the importance? In biomedical field, to know urine and blood pH. In chemical laboratories, to know nature of acid, base and neutral solutions. In paper and textile industries, in city water supply, in agriculture field, to know soil nature. So importance of the pH is very wide. You can see here in routine life in biomedical field, blood and urine pH plays very important role. In chemical laboratories especially, you can find out what is the solution pH, whether it is acid, base or neutral. In paper and textile industries, in city water supply, in agriculture field to know the soil nature. So these are the various applications of the pH in the different field. So this justifies our 5 marks. Let us move ahead. Pitting corrosion. What is pitting corrosion? Again, they have divided this question into 2 subparts, that is pitting corrosion and N-type semiconductor. Pitting corrosion first we will take up. The first short note, okay, the part of metal which is covered with rust, scale, dirt gets less oxygen than compared to the rest of part. So this part that is actually having the lower concentration of oxygen will act as anode, and the other part which is having the higher concentration of oxygen will act as cathode. So, and always remember, corrosion begins from the anode. In the pitting corrosion, what happens? More deeper and deeper cavity is formed, which results in formation of pinholes, pits and cavities in metal, and that is why it is known as a pitting corrosion. Once the corrosion begins from anode, it tries to cover the entire surface area, and due to this, holes, pits and cavities are generated, which results in the pitting corrosion. So this is something about pitting corrosion. Let us try to take the next short note, that is N-type semiconductor. N-type semiconductor, that is question 4b, second part. First thing that you are supposed to write in this is how N-type semiconductor is formed. It is formed by addition of pentavalent impurity of arsenic in silicon or germanium. Okay, out of 5 valence electrons of arsenic, what happens? You are adding pentavalent impurity of whom? Arsenic in silicon or germanium. Now when you are adding pentavalent impurity, it means it is going to have 5 valence electrons, right? So out of 5 valence electrons of arsenic, 4 electrons are in forming covalent bond with the germanium atom. So out of 5 electrons of arsenic, 4 electrons will form a covalent bond with the germanium, and the 5th electron acts as an extra free electron, and this 5th electron is responsible for conduction of the electricity. You can see very clearly here. Thus, the conductivity of germanium or silicon is due to addition of pentavalent impurity. Hence, here extra electron is responsible for conduction. Okay, the 5th electron actually that you are adding of the pentavalent impurity is chiefly responsible for the conduction, and hence it is called the N-type semiconductor. In N-type semiconductor, the conduction of electricity is due to the negative charge carrier, and this negative charge carrier is basically your electrons, and due to this reason the semiconductor is named as a N-type semiconductor. Okay, this because of the addition of the pentavalent impurity. The 5th extra electron itself is responsible for conduction of electricity in the N-type semiconductor. So this one has to cover in the entire short note whenever you are writing such questions. So we have seen many things. Now we will go to the question 4c. What is electrochemical series? Electrochemical series is basically very important series, and we are trying to first define it and then state its importance. It is the most important question that is asked in GTU, always having a very good marks weightage. So we should ensure the good marks to be covered while writing the answer also. The series in which different electrodes are arranged in decreasing order of their standard oxidation potential is called electrochemical series. Okay, so what happens in electrochemical series? Different electrodes are arranged in decreasing order of their standard oxidation potential values, that is EOX values. Okay, so these EOX values of the different metal electrodes are basically arranged in the decreasing order, and this is known as your electrochemical series. What is the importance of this series? See here the importance of the series. The metal which occupies the highest position in series is most reactive metal. Metal which are above hydrogen in position gets corroded easily in presence of acid. So series is very important. When you write down the table for that, it's not possible to learn entire table. So we have just highlighted the importance. That is very important. Metal which is occupying the very topmost position is most reactive metal. The second point says that all the metal above hydrogen in position gets corroded easily in presence of acid. The third point says when two metals are in electrical contact in presence of electrolyte, the more active metal suffers corrosion. What is the meaning of more active metal? The metal which is above the other metal, that is the most active metal, okay, and that is the most reactive metal, that is going to suffer the corrosion. The next thing of the importance continues. Rate of corrosion depends on difference in position of two metals in series. What does this means? That what is the difference in potential between the two metals, that is going to determine the rate of corrosion. If the difference between the two metals in series is large, it means the rate of corrosion is also large, and if the two metal difference position is less, then the rate of corrosion is also less. The last point in the series is it states something related to delta E value, that is positive value of delta E indicates oxidation of metal and negative value of delta E indicates reduction of metal. So the final delta E value, that is E of left hand electrode minus E of right hand electrode, if it turns out to be positive, that indicates oxidation of metal, and if it turns out to be negative, then it indicates the reduction of the metal. In general, we have highlighted all the points in importance of series, that is most reactive metal is the topmost metal in the series, that is highest position in the series, okay. Second point, metal which are above hydrogen in the series always get corroded in presence of the acid. When two metals are in electrical contact in presence of electrolyte, the more active metal suffers corrosion, and you can see the rate of corrosion depends on the difference in position of two metals in series. Positive value of delta E indicates oxidation of metal and negative value of delta E indicates reduction of metal. That's it for today. Thank you so much for being with us. Thank you.